right, class, this video is going to cover the first part of section 2.1, relations and functions. Our objectives for this video: determine the domain and range from a given relation. Also, we're going to define when a relation is either discrete or continuous. And then lastly, we're going to identify when a graph displays a function or not by using the vertical line test. So let's go ahead and get started. First, a little bit of review, just a couple definitions. First definition is domain, the set of all x coordinates from a relation of ordered pairs. Second definition, range, the set of all y coordinates from a relation of ordered pairs. So let's say, for example, I have the relation below, and it has 4 ordered pairs. And let's say, from those ordered pairs, I was supposed to identify the domain and range of each one. First, let's start with the domain. By definition, since the domain is all x coordinates, I just have to identify all the x coordinates of the ordered pairs, and voila, I have my domain. And when it comes to identifying the domain, make sure you list them from the smallest number to the biggest number. So since the smallest number is -3, you're going to write -3 next. And then after that, the second smallest number is 0, and then 1, and then 2. And just like that, you have your domain. The range, very simple and very similar. Try this one on your own. All right, you guys should have identified the range by now. Of course, the range is just all the y coordinates. And again, you have to order them from the smallest number to the largest. Since the smallest number in this case is -7, you will write that first. And then will come -5, and then 3, and then lastly 4. And that's it. That's the domain of this relation and the range of this relation. Just a basic review of stuff you learned from Algebra 1, now in Algebra 2. So that's domain and range. Now let's move on to the next topic. A relation in which the domain is a set of individual points, like the relation in graph A, which is below, is said to be a discrete relation. So in other words, if you look at graph A down here, anytime you have a graph that's just a set of finite points, then that is said to be a discrete relation. Now notice that its graph consists of points that are not connected. That's the main thing, is since the points are not connected, they are considered finite, and thus they are discrete. But now let's take a look at graph B on the other side. When the domain of a relation has an infinite number of elements, and the relation can be graphed with a line or a smooth curve, the relation is then called a continuous relation. So in other words, anytime, if you look at graph B, anytime you have a graph of a continuous line, this should instantly tell you that this is a continuous relation. And what a line represents, it represents the infinite amount of points on a line. So in other words, within this line, there are an infinite amount of points within that line. Or in other words, so many lines are in that, so many points are in that line that you cannot count them. They will go on forever and ever to infinity and beyond. Toy Story joke. So now take a moment, look at the graph on the right, and state whether the function is discrete or continuous. And of course, some of you have already guessed that on the bottom, it already stated the answer. Because the graph is a solid line without breaks, the function is continuous. Some of you may have got stumped because you saw these 5 points right here and thought, oh, those are points, so that might be discrete. But don't be fooled. These are just 5 points it's only 5 points, but also remember, those are 5 points along with the infinite number of points also on that same line, thus making this graph continuous. So, discrete versus continuous, pretty straightforward. Discrete is just going to be points, continuous should be a line. Next topic is the vertical line test. Most of you should have learned about the vertical line test back in Algebra 1 and maybe in geometry. For those of you who are not familiar with it, basically the vertical line test is when you take a vertical line and you basically make it go through your graph. You have to check the entire graph, make that vertical line go through the entire graph. And if you go through the graph, and if it intercepts only once for every vertical line, then by definition, the graph can be called a function. So then if you look at this graph that we just put a bunch of lines through, you would consider this a function because every single vertical line that went through the graph only went through the graph once, and only once. Now, for an example that is not a function, look to the graph on your right. The moment you put a vertical line through this graph, you'll notice that, oh, it intercepts not only once, but twice. So if it intercepts twice or more through a vertical line, then you would consider this not a function. The moment you find where a vertical line intercepts twice or more, you instantly say, not a function. Otherwise, you can consider it to be a function. So, just to put your new knowledge to the test, take a look at these two graphs. Use the vertical line test to determine if the graphs below are functions are or not. Take a moment to determine that now. All right, for the first graph, if you took a vertical line and if you made it go through that graph, you'll instantly see there is at least one line that intercepts the graph more than once when you take it vertically. So in other words, this would be considered not a function. And if you haven't already, take a look at the second graph and do the same thing. All right, if you did your vertical line test for the second graph, you'll see that no matter how many vertical lines go through your graph, it'll only intercept each vertical line once and only once. So in other words, this graph would be considered to represent a function. All right, so one more example I want to show you real quick. So this is just a real world example. Let's say the graph on your right shows the length of the Tour de France in kilometers each year from 2000 to 2009. And we have two questions. First, is the relation discrete or continuous? And then after looking at that, we need to ask ourselves, does this graph represent a function? Well, if you look at the graph, from what we know that discrete is when your data is just a bunch of points. If it's continuous, it's got to be a line. And if you look at the graph on the right, sure enough, those are just finite number of points. So, easy peasy, this graph represents a discrete relation. And now the next question, does the graph represent a function? And now, of course, from what we previously just learned, we can determine if a graph is a function or not by using the vertical line test. So let's take a vertical line through each of these points. And if each vertical line goes through 1 point and 1 point only, then we can say that this is indeed a function. So this graph represents a function by the vertical line test, or the VLT, because every single vertical line we made went through 1 and only 1 point. So just a similar simple example. Now try the same reasoning with this graph. Is the following graph discrete or continuous, and is it a function? Try this on your own now. All right, you guys should have finished by now. The first question, is it discrete or continuous? That was the easy part. Of course, it's discrete because it is just a plot of points. It is not continuous because continuous has to be a line. So it's not that one. But now, does this graph represent a function? Well, let's take a look at each of these points and put a vertical line through it. That was a bad vertical line. Let's try this again. Vertical line, that's good. Vertical line, that's good. Vertical line, uh-oh. We found a vertical line that went through not only 1, but 2 points. And anytime it goes through 2 points or more, it is not a function. Done. So there you have it, kids. We've covered the definition of domain and range. We know the difference between discrete and continuous. And we also know how to use the vertical line test to determine if a graph is a function or not. So with that said, your homework due on Tuesday is page 65, numbers 14. And I have already provided you with the graph paper for the graph on this problem. For parts B and D, however, please show your work and your answers on the blank space provided next to the graph paper. And with that, I will see you next time.